Hi, I'm Kate, and in this video we're going to be working on fractions, percentages and ratios. They are really important topics in everyday life. I find myself using percentages all the time in shopping. Let's say I'm at the supermarket, I'm trying to buy myself the best value block of cheese. Well, I can get a large block of cheese for the lowest price per 100 grams, but then I spot the offer. Buy two smaller blocks, save 20%. Now I'm thinking, how does that compare? What's the price per 100 grams when I've bought two blocks and taken 20% off, which is actually the better value block of cheese? And all the time I've got a small person shouting at me, Mummy, hurry up, while I'm trying to do my weekly challenge of my maths in my head. Keeps life interesting. For anyone dealing with data, these are going to be really important topics. You're going to be using percentages almost certainly. If you're using formulae of any sort, you're likely to be using fractions, and ratios creep in there too. So let's begin with fractions. As I said, most of the formulae that you are going to use will usually involve fractions. If we take speed as an example, you're doing distance divided by time. This is an example of a simple formula where you just need to type in the distance divided by the time, and then you're simply thinking, what is the correct number of significant figures for my answer, and what are the correct units? If you're unsure on either of these, please do have a look at my earlier videos. However, when we get to more complex calculations, you are going to need to use BIDMAS. I have to confess, this is something that I use all the time without even thinking about it. It's second nature. That's how you want it to be, okay? I actually had to look this up though to remind myself what BIDMAS stands for. So for the B, we've got brackets. That's the first thing that you need to do. Then we have indices, simply meaning the powers. Is it raised to the power 2? Is it raised to the power 3? After that, it's division and multiplication, followed finally by addition and subtraction. That is the order in which your calculator will do the things that you type into it. Let's have a little look at this example under here. Okay, what I have done here is put brackets in different places to illustrate their importance in the answers that you get out. What I would like you to do is have a go at typing these into your calculator exactly as they are written and seeing what answers you get out. Pause now. Okay, let's take a look at the answers that you should have got. Did you get these? Interestingly, just by putting brackets in different places, the answers will vary from minus 186 as the lowest to 80 at the highest. I hope this illustrates the need to use brackets really carefully. Simply thinking about BIDMAS makes a huge difference to your answers. And if you're not putting brackets into your calculations correctly, it doesn't matter what else you do because your answer is going to be incorrect. And I do see this all the time with students. They can do the calculations, but they put it into their calculator and the wrong answer comes out despite all of their knowledge. So let's get this sorted. If you're doing fractions, there's something that you need to know. They have invisible brackets on the top and the bottom. People often don't know this. And even though they're not written, when you're typing in this calculation into your calculator, you need to put those invisible brackets in. So if we do this as an example, 35 plus 11 divided by 21 plus 18, each of those has an invisible bracket around it. And that means that the brackets get done first before the division. When you type it in like this, you get an answer of 1.2 to two significant figures because all of our data is given to two significant figures. However, if you don't put the brackets in and you simply type it in as it's written, your answer will come out as 54 to two significant figures, which is dramatically different. This one is correct. This one is incorrect. Okay, so what I'm giving you here is an example of a formula. It's for percentage atom economy, which is something that we do in chemistry. It doesn't matter if you're not familiar with it. What you're going to do is your molecular mass of your desired product divided by the sum of the molecular masses of all the reactants multiplied by 100. So you have your data here. You've got the molecular mass of your desired product and you've got the molecular masses of both reactants. So what I'd like you to do is have a go at putting this into the calculation and make sure you give me the answer to the correct number of significant figures. Pause now. Okay, Let's take a look. This is the answer that you should have got, 32.5, and that should be to 3 significant figures. Let's have a look at how you should have got that. So we're putting the data in, so 34 for the desired product divided by 64.5 plus 40 for your reactants. However, don't forget we have invisible brackets which we need to put in. So when we type this into the calculator, including our invisible brackets, we're actually doing 34 divided by 104.5 and then multiplying it by 100. That gives you 32.535. We look back at our data, each of them is given to 3 sig figs. Okay, so that means that this needs to be given to 3 sig figs. That is your third significant figure there. That rounds it down and you get 32.5 as your answer. So moving on to percentages. Percent means out of 100. And typically when you're working with percentages, you're going to need to either multiply or divide by 100, depending on exactly what the calculation is asking you to do. So this should be second nature, should be simple, but let's have a little look because you may not have used them for a while, you might be a bit rusty. Okay, so the first thing we're going to look at then is how you find one number as a percentage of another. In this instance, you are dividing the first number by the second before multiplying your answer by 100. So let's take a look at an example. We have 13 children in the class of 29 that have brown eyes. You need to find the percentage of children with brown eyes. Pause now. Okay, your answer should be 45% to 2 significant figures. Let's take a look at how we got that. So we are doing the first number 13 divided by the second number 29 and then multiplying by 100, giving us 44.827. We need to give an answer to 2 significant figures. That is our second significant figure. The 8 rounds it up. So that becomes 45% to 2 sig figs. The second way you might need to use percentages is to find the percentage of a number, in which case you take your percentage and you divide it by 100 and then multiply the number by the answer to that. Let's take a look at an example. You're told 55% of children in a class of 29 have brown hair. You need to calculate how many children have brown hair. Pause now. Let's take a look at the answer. Your answer should be 16 to 2 significant figures. Now, how did I get that? Well, I'm taking the percentage, which is 55, so 55, dividing that by 100, and then multiplying it by the number. Okay, so when I do that, I get 15.95. I need to round this to 2 significant figures to match the data. So that gives me 16. One final point, do remember that percentages add up to 100, so that if you don't have all the data, you can find that missing piece of data by simply totaling your percentages and subtracting from 100. So let's take a look at this example. In a class of children, 22% have blonde hair, 34% have black hair, 9% have red hair, and you're told the remainder have brown hair. And the question asks, what percentage have brown hair? Pause now. So your answer should be 35%. So you're doing 100 minus the sum of the other percentages that you've been given in the question. Hopefully that was just a quick recap for you. Right, so ratios next. Now these are things that people are typically less confident on. There's no big deal to it, okay? We'll take you through it and simply show you what we're doing. So we can use ratios to compare 2 things or more. Here we're looking at 2. So we have squares and we have triangles. We're going to look at the ratio of squares to triangles. So we're simply adding them up. We have 5 squares and then we put in our ratio sign, the double dot, and we have 4 triangles. So the ratio is 5 to 4. We can use ratios for any number of numbers, okay? So here we have squares, we have triangles, we have circles. We have 5 squares again, so ratio 5 to 4 triangles to 3 circles. Okay, so the ratio is 5 to 4 to 3. Let's talk about equivalent ratios. Typically, when you're giving a ratio, you want to give it in the simplest whole number form. And you just need to remember that as long as you multiply or divide all of the numbers in a ratio by the same number, then you will have equivalent ratios. So for our example, if we have a ratio of 60 to 30, I'm going to try dividing by 10, and that's going to give me a ratio of 6 to 3. I can simplify this still further if I divide by 3, and I get a final simplified ratio of 2 to 1. All of these ratios are equivalent. 2 to 1 is the best way to express the ratio though, because that is in its simplest whole number form. Right, an example for you to try then, I'm giving you the molecular formula of glucose, C6H12O6. This is simply giving you the ratio of the number of atoms of each element. I would like you to find the simplest whole number ratio of the elements. Pause now. The answer should be 1 to 2 to 1. Let's have a look at how I got that. So I'm using the same order that the data has been given to me in. This is really important. So I have C to H to O. I'm making sure I write in the correct numbers underneath each of those. So 6 to 12 to 6. I can then divide through by 6 to get the simplest whole number ratio of 1 to 2 to 1. Okay, that's it. We've gone through the percentages. We've gone through fractions and we've gone through ratios. If you felt at all rusty on any of that, do please have a go at the consolidation exercises to embed what we've worked through today. Thanks for working through it with me. Bye.